Okay, we are here on lesson 4.4 notes, graphing rational functions. We're going to use what we learned in 4.3 to help us graph rational functions, and then, but we'll need to use a few more things than just what we learned last time. Just kind of remind ourselves about quick throwback to Algebra 1 when finding x-intercepts. To find x-intercept, you're going to let y equals 0, okay? And so remember that is when you have x and a 0, it's a point, don't forget, okay? And then to find x-intercepts on a rational function, you're going to set the numerator equal to 0. Okay? That's the only thing to set numerator, and we'll do some examples of that, so I'll make sure you pay attention to that. So on here, remember this is a point, so this is a point. Write it as such, okay? To find the y-intercepts, we let x equals 0. Again, this is a point. Okay. All right, so using all that. So we're going to talk about using vertical, horizontal, holes, x and y intercepts, and then we're going to sketch the graph, okay? So the first thing we're going to do, and then one thing that we're extra going to have to do is find an extra point, okay? So we'll talk about that as we go. So let's just do a few things. So first thing we're going to do is that we are going to find the vertical asymptote. So again, we look at it, the function, we cannot factor it from yesterday. This is not factorable, number 1. So we are going to leave it as it is. So when you want to find, I'm just going to go on vertical asymptote, okay? We're going to set the denominator equals 0. So vertical asymptote, x plus 3 equals 0, x equals negative 3. This is an equation. Please write as such, okay? The horizontal asymptote, remember we determined by looking at the degree of the numerator and the degree of the denominator. So for the degree of this numerator, it's degree of 1, and then the denominator is degree of 1 as well. So since they're the same, it's actually the coefficient of the numerator and denominator. So remember, it's y equals, the coefficient of the numerator is 1, the leading coefficient numerator of the bottom is 1. So our equation is y equals 1. Okay, so let's look at the whole. We did not cancel anything out, so therefore there's no hole. So make sure that you do please write no hole or write none. Don't leave it blank. Okay, so I know that you know. Okay, and the next thing we'll look is the x-intercept. All right, for the x-intercept, we are to, according to up here, is set the numerator equal to 0. Well, my numerator up here is x minus 5. Okay, so x minus 5 equals 0, so x equals 5. So, but y is always 0 when you're dealing with an x-intercept, so the point is 5, 0. For the y-intercept, you're going to substitute in place of x a 0. So you would have f of x equals 0 minus 5. I'm putting it into the original equation over here. And 0 plus 3, which gives me a negative 5/3. So again, I have a point at 0, negative 5/3. For graphing's sake, you might want to change this to negative 1 2/3. Okay, so we graph it. Now, so let's look at what we have here when we graph it. So let's usually graph your asymptotes first. Those are better because you can kind of see where the graph should be going. So we have an asymptote at x equals negative 3. Negative 3. Another asymptote at y equals 1. I'm just doing the same color on my paper. Y equals 1. Okay. Then I would plot the only points we have on here, which is our x and y intercepts. So our x-intercept, we have 5, 0. Our y-intercept, we have 0, negative 5/3. So that's, again, negative 1 2/3. So that's the only reason I wanted to change it. Okay, so because this is a rational function, rational functions have some sort of shape, usually like this or like this. That's what it looks like parent function-wise. We're not doing anything, but this for area down here at this bottom area. Okay, it's kind of, you can kind of see where the graph is, where the points are for the graph. So what I'm going to do is I'm going to use that to help me draw my graphs. So if I draw my graph, I'm going from here, it's going through here, it's going to go through here, and then start to go up close to that. Okay, and down this way. Okay, so now the other thing is the rational function has two parts to it. Okay, if you have an asymptote there, you have something on the other side. Okay, so if you look at, this was down here, so I know something must be over here, so I have to put something in this quadrant up here. Okay, oops, in this quadrant right here. So what you need to do is you need to find a point. So what we're going to do is we're going to find a point that we want to use to substitute in there. So pay attention to where it's at. We're up here. We want the graph to be up here in this area up here. I don't know if you see that part. This area up here, okay? We want something up there. So we want one of these x values that's past the asymptote. So let's just pick x to be -4, okay? So you want to use any x value. So I want to find this extra point. I'm going to put my info here. Down here, must find another point on the other branch to determine what the quadrant, which quadrant belongs in. So look on the other side of the x, the asymptote. So for extra point, okay, for other branch, and I'm talking about branch, and just these things I've circled there, okay? Use any x value left of the vertical asymptote. Since my vertical asymptote is x is -3, I'm going to choose x to be -4, okay? So now substitute it in, so f of x equals -4 minus 5 over -4 plus 3, which gives me a -9 over -1, which equals just 9. So my extra point is at -4, -9. So I go here, -4, -9 is somewhere up this way. So I'll just plot there. So I know the graph is going to go this direction. Unfortunately, we're assuming that it's up that direction. We can't really, I shouldn't really put the dot right there. But just know that it's not going to be, it's up in that direction. It's not going to be totally exact, but as long as it's curving in that direction. Okay? So that's your graph. Okay. Example number 2. Analyze function and sketch the graph. Analyze function to get all the parts that we need. So first thing we're going to do, let's determine the vertical asymptote. So the first thing you want to do, though, before that is always factor. So let's factor. So f of x equals x minus 2 over x plus 4, x minus 2. Okay, so I factored. Now can I cancel? Yes, I have x minus 2 and x minus 2 the same. So make sure you cancel that. But remember, this is a 1 on top. It doesn't go away because you cancel it out. It's really that divided by x minus 2, which is 1. So now to write my simplified function, it is f of x equals 1 over x plus 4. Okay, so you need that to help you to write your vertical asymptotes, your holes, anything. Okay, so first things first, do I have vertical asymptote? Yes. After we simplify, we have a variable in the denominator, so we have an asymptote, okay? So we're going to set x plus 4 equal to 0. So x equals -4. That is my vertical asymptote. X equals -4. Okay. Now do I have a hole? Yes, I canceled, so I have to have a hole. So I'm going to take my canceled portion, which is the x minus 2, solve for x, get a 2. Remember, that's the x value. We have a point. And then I'm going to substitute that into my simplified function. So I'm going to do 1 over 2 plus 4. That gives me 1 over 6. So my hole is at 2 and 1/6. Next, I look at the horizontal asymptote. Okay, so I look at the numerator. This numerator is a degree of 1. Okay. This numerator is a degree of 2. So that means my numerator is less than our denominator, so I have an asymptote horizontal at y equals 0. Okay. X-intercepts. So to find the x-intercepts, I look at my simplified version, which is this right here, and I look at this. Okay. There is no variable, so I can't set x equals this, so there is no x-intercept. It will not cross the x-axis. Okay, again, I set the equal to 1 equals 0, doesn't make any sense, so you can't do that. So the y-intercept, all right, we're going to let x equal 0. So for my y-intercept, I'm going to let x equal 0. So I get 1/4. So 0, 1/4. Okay. Now, what I would do first is I would draw, kind of get an idea of what the graph looks like, so we know where to look for the vertical asymptote. Okay, see if we can figure out where the thing is going. So if I plot my vertical asymptote at x equals -4, which is here, I have a horizontal asymptote at y equals 0, so please show that on your number line, because you need to kind of see it for yourself anyways, okay? I know I don't have any x-intercepts, but I do have a y-intercept at 0 and 1/4, which is just a little small thing here, right here, okay? And then I know I have a hole at 2 and 1/6. Okay, so 2, 1/6. So put a hole here. Okay, so that means this graph has to go in this direction because the end behavior is determined. So you can't cross the vertical asymptote, excuse me. So you're going to cross this, getting close to this, not quite sure exactly. We can pick more values if we want to. The hole, don't cross the hole. And that's getting closer and closer to that 0. Sorry, that should be like a, make sure I can see your intercepts when you, that's a hole, sorry. I'm trying to draw it down in there. Okay, so now what I want to, like, again, find an extra point on the other side of the, to the left of the vertical asymptote. So we have a -5 is the next point. So if I let x equal -5, okay, you're going to substitute into your simplified function. So y equals 1 over -5 plus 4, and then which is 1 over -1, which is -1. So I have an extra point at -5, -1. So based on that, when I graph it, I know that it's going to be down in this quadrant. So that means I'm going to have to make sure my graph goes this way. Crosses goes that direction. All right, number 3. First thing again, always factor. So So f of x equals x plus 3, x plus 2 over x plus 3. We will cancel. And so our simplified function is f of x equals x plus 2. Okay, so let's go in order of this. Vertical asymptote. When looking at this function, is there any variable in the denominator? No, so therefore there is no vertical asymptote, so please put none. Wholes. Did we cancel out anything? Yes. We canceled out x plus 3. Okay, so we're going to let x equal, we're going to take x plus 3, so it equals 0. We get x equals negative 3. So that is my x value for this, for the whole. Then I'm going to take it, substitute into the simplified expression. And if you want to write y equals, it's just a habit to write, I'll just do that for this one. X plus 2, so y equals negative 3 plus 2, y equals a negative 1. So my point is, my whole is at negative 3, negative 1. There's the whole. Okay, horizontal asymptote. It looks like the degree here is 2, the degree down here is 1. Since the numerator is greater than the denominator, there is no horizontal, so please write the word none. Don't leave it blank. And then your x-intercepts. So we're going to set the numerator, which is x plus 2 equal to 0. So x plus 2 equals 0, so x equals negative 2. So we have a x-intercept at negative 2, 0. And then now we're going to set x equal to 0. So for the other one, so we get y equals 0 plus 2. So then our other point is 0, 2. Okay. All right, so let's see. If we go over here and draw our equation, so we have a hole at negative 3, 1. So it's very important. Negative 3, 1. That's where my hole is. Negative 3, negative 1. There's a hole for the graph here. Okay. We have an x-intercept at negative 2, 0. So that's here, and it's closed. And then we have a y-intercept at 0, 2. So because we should know that this is what we're graphing, that's the equation of a line, okay? We don't necessarily need extra points. We know the slope is 1. So if you're trying to figure out how to go from this hole, up, down, you're trying to go up this way because it's 1. All right, so then you draw a straight line. Again, do not I wish I had my ruler on this one, but this thing does not have that. So these are our extra points. Again, you don't have to draw those, but make sure you realize it's a straight line passing through those points. Make sure I can see these points, those intercepts, holes, and so forth, okay? If I can't see them, I'm not going to count them as that they're done. All right, number 4, let's factor. Always, always factor. So f of x equals, we should get a 2x here, x here. So do 5 here, or do we want to do 5 there? This needs to be a 1, this needs to be a 5. Okay. Factor this is x minus 5, x plus 5. So that's factored, okay? We're going to cancel our x plus 5s out. Our simplified version is f of x equals 2x minus 1 over x minus 5. 2x plus 1 over 5x minus 5. Okay, vertical asymptotes. So do we have a variable denominator? Yes. So we're going to set x minus 5 equals 0. We get x equals 5. So you have a vertical asymptote at x equals 5. Okay, do you have a hole? Yes. Because you factored and canceled something out, you do have a hole. Okay, so we are going to use the part that we factored out. So we'll do the x plus 5, set that equals 0, we get x equals -5. Okay, so that's our x value for the hole. Now take that, substitute into a simplified equation up here. So in place of the x up here, I'm going to do 2 times -5 plus 1 over -5 minus 5. I should actually put here -5. Okay, so that's going to give me a -10 plus 1 over -10. So this is -9 over -10, which is 9/10. So my point is that hole is at -5 and 9/10. Okay. Horizontal asymptote. So we look at the numerator and the denominator. So the degree here is 2 and the degree here is 2. So we want to find that, we do, for the horizontal asymptote, let's do down here. So the y equals the leading coefficient of the numerator divided by the leading coefficient of the denominator. So our leading coefficient of the numerator is 2 and the denominator is 1. So y equals 2 is our horizontal asymptote. X-intercept, so we look at the numerator only and we set that equal to 0. Okay, so for my x-intercept, I'm going to set the numerator equals 0, 2x plus 1 equals 0, 2x equals -1, x equals -1/2. So we have a -1/2, 0. Okay, and then for the y-intercept, let's do this color. We're going to let x equal 0 in our simplified function. So 2 times 0 plus 1 divided by 0 minus 5. So that equals 1, -5. So we have a 0 and -1/5. Okay, and we probably will need an extra point. So, and this time it's kind of hard to do it to the left. So what this one, other ones we set it to the left. So that just happened to be for that one and the other one that we found. So let's plot everything that we know so far. So we have a vertical asymptote at 5. We have a horizontal asymptote at 2. Okay, we have a hole at -5 and 9/10. It's a very, very small number here. So -5 and 9/10 is closer to 1, so it's right here. And then we have an x-intercept at -1/2, 0. So -1/2, 0 is here. And then we have at 1 at 0, -1/5, which is really small here. Oops, sorry. 0 and -1/5, which is right here. Really small. Okay, so this graph has to come from this direction, from the left here. And so our end behavior, remember, helps us. So if you think about our end behavior and how to draw this, it's getting close to this line, so but it's got to come through this hole. Say that's a hole. And then it's going to come over and go through these two and try to get close and close to this one as possible as it goes down. So again, end behavior is getting close to the and this is, I'll make this sure to show you, this is a hole right here. Okay, and that's an x and y intercept on those red ones. Now the only thing is we need the next one, so we're going to go to the right of it this time because we already have a graph on the left. So this time go to the right of it, and if we just pick x equals 6, you can pick any of those values you want there, but if I let x equals 6, from an extra point, I'm going to let x equals 6. So substitute it again to our 2x plus 1 over x minus 5. So 2 times 6 plus 1 over 6 minus 5, which equals 12 plus 1 is, so so I have 12 over 12 plus 1, which is 13 over 6. Oh, excuse me, 1. So my point, we have a 13. So the point is that extra point is at 6. I'm going to put it right here, comma 13. So I'm going to go over here and plot that. 6, so 13 is way up here. So we know the graph has to go this way. Okay, the end behavior tells me it has to get close to this. And then go out that way. So kind of failed to mention up here at the top, so going back to number 1 and talking about that horizontal asymptote and the end behavior. So if you notice, here's your horizontal asymptote right here. And then this graph, the end behavior of it, as x gets larger, it's going close to that 1. And over here at the top, when x is getting smaller, it's still going towards that 1. So that y equals 1 is an end behavior. Same thing here. It's not a great graph, but as x gets larger, it's getting close to 0. And as x is getting smaller, the end of my graph is going towards that 0. So the end behavior does that. Now, if I look at number 3, we don't have an end behavior. There's no reason to say what each of this graph is as it's approaching. It's not approaching anything as x, this is still getting, as x gets larger, this value is going here, this direction, this direction. We don't talk about end behavior when it comes to a horizontal asymptote because there is not one. So I just want to kind of bring that up. So, okay, here is 4.4 all done.